Good morning, guys. Today we're going to look at compound interest. And basically, when you're doing compound interest, your interest earns interest. So you put money in the bank to start with, that earns interest, that interest stays in there, and now you're earning money on the interest. So we have a little bit different formula, and there is a typo on there. So it should be A equals P times 1 plus R over N. And that power on there, I think if you printed out the worksheet, it says to the RT power. It should be to the NT power. Okay, and what do all these things mean? Okay, well, the A is still the amount at the end that you end up with. P is still your principal or your starting amount, right? How much money you put in. R is the interest rate still. And again, remember, we want that as a decimal. N is going to be the number of times per year that you calculate the interest, and T is your time. So if you look at some of the common values that we use for N, annually, N is going to equal 1. Okay, semi-annually, N would equal 2. Quarterly means you're going to do it 4 times per year. Monthly, well, how many months are in a year? Yes, 12. And daily, let's assume it's not leap year. There's going to be 365. Now, what if it's being compounded continuously? Again, that's the formula we used in the last section. And you would just use that one instead. Okay. Okay, so basically, this is word problems, right? Money is real world. So write an equation to find out the amount an account will have that started with $5,500, interest compounded monthly at a rate of 5.15 for 20 years. So we want to know how much we're going to end up with. But we started with 5,500. It's 1 plus, and again, what's my rate? 5.15% means 0.0515. N, again, is the number of times that it's being compounded per year, so this is monthly. So we're going to put that as a 12, and then 12T, okay? And then this one said for 20 years, so we would just plug in a 20 on that. So that's sort of my general equation for this, for how much would it be anytime. And to solve it, okay. And again, if I plug this into my calculator, if I put it in my graphing calculator all together, I can just type it in like that. If I were doing it separately, I'd probably go 0.0515 divided by 12, add 1 to it, put that to the power of 12 times 20, and then multiply by my answer by 5,500. And the amount we're going to end up with after 20 years is $15,371.95. Okay. And you have to ask yourself, does that seem reasonable? So basically in 20 years, am I going to triple the amount of money that I have in there, just for checking. Write an equation to find out the amount an account will have that started with $4,500. Interest compounded quarterly. There's my rate of 3.8%. And I'm going to go 25 years. So again, I'm going to plug in 4,500 times 1 plus, what am I going to put in as my interest rate? Yep, 0.038. How many times per year is this going to be compounded? Quarterly means my number will be 4. And then it's to the 4t power. So again, and this is going to be 4 times 25. So again, I plug that all into my calculator, and of course make sure that's 4 times 25, not 4.25. I'm not putting in an x for times because x is a variable at this point, right? And I should get $11,583.63. Okay. We're also going to look at how you can use essentially this same formula to just compare interest rates over time. I'm going to do that on a second video though, because if the videos get too long, they have a problem uploading to YouTube. So check back for the second part in just a minute.